To begin with, let's download the PicoTech software. Okay, you go to picotech.com, downloads, and the series that we want to select is called the PicoScope 2000. So I click on this, and the actual model number that we're using is the 2204A. So click on this, software, and I'd like to download this software version here, the 7.2.10. It's the stable version. I already have it downloaded, so I won't do it right now. This is the PicoScope 2000 series oscilloscope. This is what we'll be using in the lab class, and notice that we're connected to channel A and to channel B. These are the input channels. The third connection is for the generator output, which we won't be using. These are the two oscilloscope probes, one for channel A and one for channel B. And here I have some connections to two wires at the tips of the probes. And I'll circle these. And you must also have a ground connection. After that, you want to make sure that these two slide switches are set to ×10. That's the hardware setting, and you'll also have to set it to ×10 in the software. Hello, here I have a PicoScope capture, and I'm actually running a program on the Arduino that's outputting a pulsive modulated signal, and that's what I'm measuring. So I want to point out a few different parts of the screen that will be important to you. The first is the vertical setting. So I'm telling the system here that I want to measure a signal between +10, and you'll see that marker up here, all the way down to -10 volts. And in the center of that is 0 volts. So you can tell by the markings here that my voltage is somewhere between 4 and 5 volts. So that's the vertical setting. And you remember previously I talked about the ×10. Well, this is the software setting to match up with the hardware on the scope probe. So that's the vertical setting. If you want to make changes, you just click on this box, and this is where you go to set up the verticals, the probes, and sometimes the display. Okay, we'll talk about that later on. But that's the probe setting. So once we've done that, another place to look at is the time per division setting. This is the horizontal setting. It's telling us the time per each of these divisions. Here's 1, 2, 3, and so on divisions. And down at the bottom here, it tells you 0 milliseconds, 1, 2, 3, and so on. Okay, so that's an important part. Another thing to look at is the trigger. The trigger is up here. I'm going to click on that panel. And there's a lot of different choices and settings that you have to go through. So the first one, when we have a signal that's like this, it just keeps repeating, we'll want to go to auto trigger, and you'll notice that kind of freezes the digital signal that's being displayed. And I want to trigger on source A because that's the channel I'm working with, and the threshold point is some vertical point where we want to trigger on. And you don't want it to be near the top because of the noise, not near the bottom because of the noise, but somewhere in between. And I can change that value. So it still works fine when we're down here, still works fine when we're up here. But if we get close to that noise, it won't work properly anymore. It just won't trigger correctly. So be somewhere in that middle section. The other thing to notice is the direction is rising. We're going from a low level to a high level. That's rising. You can do the opposite and go from a high to a low and trigger on that. But I prefer to generally use rising. Once you've set that, you have something called pre-trigger. Each of these squares represent a certain percentage across the screen. So I've got it set to 20%, which is right here. I can move it over to 30, 40, 50, but I generally like to set it at 20%. And that's because I mostly want to see what happens after the trigger. So those are the main three things. The vertical setting up here, the time per division, and it's easiest to switch that just by clicking the plus and minus. And that's actually too many cycles on the screen, and this might be too few. But 5 to 10 is a good number to have, or 4 to 10 is a good number to have. So I do have that in this example. In this next section of the video, we're going to look at different types of measurements. And to go to the measurements menu, you select this icon. Looks like a measuring tool. And you have a choice of selecting A or B. But before we do any of that, let's just come up to settings and turn the indicators off. I've had some issues with this latest version with the indicators, but really what it does is puts markers on the screen to show you a representation of what you're trying to measure, in this case the time high. But let's turn these off for now. So we'll go back into measurements, and the first thing I want to measure is the top voltage up here, which kind of is the average of that top. So you select top, okay, and you'll get this window, and to just have it go away, just select anywhere on the screen. And now we have, and I'll delete this one, we have the top measurement right here. So it's telling you that it's about 4.6 volts. Okay, it's kind of low, but it's what my USB port is outputting. The next measurement I'd want to see is the frequency. So come back to measurements, and you'll notice that the top half is amplitude, the bottom half is time. So let's click on frequency, and then just click here. We'll add period, and this program calls period cycle time, which is okay, still true. And that's the cycle time. And then I'm going to add positive duty cycle. So that's a time measurement, positive duty cycle. And we want to do it for A. And then the high pulse width. So back to measurements and high pulse width, which is right here. And now we have 5 different measurements at the bottom of the screen. So the first one is that top voltage. Second one is the percent positive duty cycle. So it's about 40% high. Frequency, as we mentioned before, is 490 Hertz. The period about 2.04 milliseconds. And since we have 40% high, well, 40% of 2.04 milliseconds is about 800 microseconds. So all those readings are working out the way we would expect. Now I'm going to turn on the second channel, channel B, and I want to start off by setting the probes to ×10 and the vertical to plus and minus 10. And I already, no, I don't have that set, it's actually turned off. So I have to go to vertical, manual, plus and minus 10. And now you can see I have a second red line representing channel B. You can actually change the names. I could say that this is the pulse width modulation signal. And I think I double click this box and go to display. And this is where I could say that this is the pulse width modulated signal. And then I could go to B and say that this is the average DC voltage. And that way my boxes show that, and the numbers down at the bottom I think will also show that. Okay, so we have that set up. The other thing that's important that I want to add is for channel B, I want to have an offset so that it's going to rest at 0 at around this point. So I'm going to add an offset of -40. So you just do minus and 40. There are different ways to enter it, but now I have an offset of -40. And notice there's a little dashed line here showing the 0, and that gives me a better representation of my voltage, and it doesn't overlap with the top one. The other thing that I might do here is I want to put the top voltage for channel B. So it's another measurement, so measurement. Click on measurement. Sometimes there's a bit of a delay, so top. And this time I want to put it on the average DC. And since I've changed the channel names, this is very handy that you see the name right here. Okay, and then just click away. So now the average DC voltage is showing about 89 millivolts. That doesn't seem right. That's the amplitude. That's not what I wanted. So maybe I have to go to, well, let's delete this because I got the wrong setting here. That's okay. So to delete this, I'm going to go to up here into measurements, and we wanted the top voltage. Actually, I must have had amplitude instead of top. So I'm going to click on top. And the reason I knew that right away is it wasn't giving me the voltage that I expected. And we don't want it on the pulse width modulation. We want it on the average DC. Now we have that. And that's okay for top. And I'm going to delete the amplitude one. So now I have the top one. And that's making a little bit more sense because that's almost 1 volt. And what I'm going to do is adjust my pulse width modulation signal, and notice that the average DC voltage is changing along with it. So if I bring this down or bring it up, this is going through the low pass filter that's using a 22 microfarad capacitor and a 2.7K resistor, and giving us a cutoff frequency or a corner frequency of about 2.7 hertz. Okay, so it gives you some ideas. I'm adjusting that. My average DC voltage is changing. And in robotics, where we'll be using this is to adjust the speed of the motors by adjusting the percentage of high time in the pulse width modulated signal. You'll find this setting very useful, that you come up to this bar, click on Save. And it's very important that you select not PS data, but PSSettings file. And what this does is all of these changes in the settings that you've made for this particular example get saved to a file, and then you can recall that information. So I find it very, very useful. So what you can do is save it with a meaningful file name. For example, setup for lab 1. I'm just going to put ELE8941 and winter 2026. And once you've done that, click on Save. And then if you've made other changes and you want to come back and look at that, you can go to Open, and you'll see that the file is there for me already. And I just click on it, and it has all of those settings already set up. And it just takes a second, but it goes widescreen. You'll notice all the measurements down at the bottom, the 2 scope settings where the 0 is on the left, the 0 on the left, right, 0 on the left. And if you want to adjust these positions, you can do it in the percentage window, but notice how I'm bringing my mouse over to here and changing it, so I can bring that 0 right down to the bottom, and I can change that position. But I find it a little bit easier if you actually go up to here and go to display and set it for -50. So remember that setting. So that's many of the things that you're going to be doing. One of the things that you can do to simplify what you see on the screen is if you go to, I think it's views, no, not views, more, you can actually turn things on and off. For example, maybe I don't want to see the views. Maybe I don't want to see actions, and deep measure, and masks, and math channels, and reference, and serial decoding. So I don't need those for what I'm doing in this class. So that way I have less options up here. And I'll show you what Notes does. Notes allows you to do where you can just click on that, and you'll see a box that comes up on the screen. I'm looking for that. So it's right here. And it allows you to put a little box on the screen to make that measure. And let's leave these measurements up here. And everything is running the way I expect. I think I've done everything that I want to do in this demo. So I hope this helps for lab number 1. Thanks for viewing.